Hey guys, we're about to learn about how to apply angle bisectors and in particular the in-center theorem, which you just learned about in the epic Prezi video that I made. So look forward to it. It's going to be fabulous. Alright, so in this one it says UP, so segment UP, segment TP, and segment PS are angle bisectors. And this property will apply to example 1 and 2. So don't forget that initial property. Okay, so since we know that UP, TP, so this one, and PS are angle bisectors, what does an angle bisector do to an angle? Holy hot dog, you guys are so smart. It does slice it in half, which creates two congruent angles. So if I labeled my picture, since these are angle bisectors, it means that these two angles are congruent, which I have to apologize, you guys. This picture is quite ugly and I screwed it up really bad. So if you see there's a lot of white out and stuff, so I apologize. Hopefully you do a better picture than me. But anyways, these two are congruent, these two are congruent, and these two bad boys are congruent. Oh man. Okay, so we know that that's true since they're angle bisectors. Okay, but let's see what the problem presents us, and let's see if that information is even going to be helpful. Maybe it is, maybe it's not. Let's see. Okay, so in example 1, it says PC, so the length of P to the C, so this one, this little guy right here, is 2x minus 7, which, remember, it's always helpful to label our picture in geometry. So I'm going to label that piece as 2x minus 7. 2x minus 7. So that bad boy is 2x minus 7, and P to the D, so right here, PD, is x plus 4. And now it wants me to know, or now it wants to know what PB is. Well, so right now we're dealing with segments, so it doesn't really seem like these angle bisectors are going to be really helpful in this problem. Shucks, I know, we were all hoping the angles would be helpful, but they're not. So we have to figure out what's useful in the picture and what's not. So let's think back to the in-center theorem. Do you guys remember what the in-center theorem is? I knew you guys knew, but I'll recap it just in case it slipped your mind. But anyway, so the in-center theorem says that the in-center of a triangle is equidistant, which is a fancy way of saying it is the same distance to a segment that is perpendicular to the sides of the triangle. So the in-center is that point where the three angle bisectors intersect. And then if you draw perpendicular segments to the sides of the triangle, based on this theorem, they will be congruent. So let's see, maybe that will be helpful in solving the problem. I don't know. Let's see. I kind of have a good feeling about it, so let's see here. Well, I have three perpendicular segments, which I know these are perpendicular because when they hit the side of the triangle, they form a 90-degree angle. Whoa, right? So, since these three segments are perpendicular based on the in-center theorem, I know that they're congruent. So I'm going to mark that in my picture. So this segment is congruent to this segment, which is congruent to that segment. Which I was given information about this segment, so I think that's what's going to be helpful in solving this problem. This thing needs to go away. But anyways, alright, so based on this, let me identify that over here. So I'm going to say that PC is congruent to PD, which is congruent to PB, which that means that their segments are equal. So I'm just going to jump the gun and go to say that the segment lengths are equal. So P to the C, so PC equals PD, which equals PB. Alright, so if I figure out what PC and PD are, guess what, you guys? I can figure out what PB is. Alright, let's get started. So I know that PC, I was given stuff about PC and PD. And look right here, I know that they're equal. So that's going to help me solve. So I know I'm going to use the information that PC is equal to PD. Alright, and guess what? Now I just need to fill in my pieces and solve for x. But remember, in geometry, you are not necessarily done when you solve for x. You eventually have to find PB. So when you find x, you're not done. Watch yourself. The demon cats will get you if you think you're done when you solve for x. So you better be careful. Alright, so let's start filling this in. What is PC? Holy hot dog, it is 2x minus 7. So 2x minus 7 equals P to the D, which PD is x plus 4. Bam. Alright, let's solve this bad boy for x. So first, we need to join our x's together because they're besties and they're like terms and they want to be together. So I'm going to bring x over to be with 2x. What do I do to x to bring it over to 2x? Yes, I do, my brilliant students. I do subtract it on both sides because that's the opposite of a positive x. X minus x will cancel in terms of 0, and 2x minus x, which remember there's secretly a 1 in front of this x. 2x minus x will give me a 1x. Oh man, so now I have 2x minus, or sorry, not 2x. Sorry, oh gosh. The demon cats are getting me. They're getting me bad. 2x minus x is 1x, not 2x. And I just made a mark. Good golly. Alright, so I got 1x equal... Oh, man, you guys, the demon cats. 1x minus 7. Man. 1x minus 7 equals 4. Alright, now I need to move everything over to the other side so I can solve for x. So, how do I move negative 7 to the other side? Yes, I would add that bad boy on both sides. Alright, so negative 7 plus 7 cancels, and 7 plus 4 is 11. So guess what, you guys? X equals 11. Yay! But before you start celebrating, which I know you're going to celebrate when you get done with this problem, because when you get math problems right, it calls for a celebration. But anyways, we are not done. It does not say to solve for x. It says to find PB. But I don't know PB currently because I wasn't given anything about PB. But if I can figure out what PC is, and also if I could figure out what PD is, they're the same thing, and they're also the same thing as PB, because PC equals PD, which equals PB. So technically, I only have to find what PC or PD is, because both of those bad boys equal PB. But just to be sure, it wouldn't hurt to find PC and PD to make sure I did the problem right, because I could have made a math error, especially since the demon cats are getting me a lot tonight. But it would be good to find both of those, and if both of those are equal, that definitely means PB will equal whatever each of those are. So let's do that. So, PC I know is 2x minus 7, which now that I know x is 11, how could I use that piece of information to help me find PC? Yes, I would. You guys are so smart. You would substitute an 11 for x. So PC equals 2, my x, right here, is going to transform into an 11. So times 11 minus 7. Alright, let's see what we get. So 2 times 11 is 22, which I'm running out of space. Alright, I'm going to write it right here. PC equals 22 minus 7. Alright, and then 22 minus 7 will give me a 15. So PC equals 15. So if we did this right, PD will equal 15, which then means PB is definitely 15. So let's see if we get 15 again. Let's see. I hope so, because I've worked really hard on this problem, and I really don't want to make another video again. Alright, so PD is x plus 4. Alright, so now that x is 11, I can substitute that bad boy in for x and find PD. So let's see what happens. So PD equals x, which is going to transform into an 11 plus 4. Oh man, you guys have a good feeling about this. What is 11 plus 4? Oh man, it is 15. Look at that. So PC equals PD, which is true. They're both 15. And since PC equals PD, which equals PB, that means that PB is 15. Yay, we got it right. Now you guys can have your epic celebration. It's going to be the best math part of the year. That was great, you guys. Example 2 is going to be even better, so wait for it.